Hi, my name's Nick. I'm the founder of Rare Combinations LLC and the inventor of the Rare Combinations alcohol content detector. Originally, I was a kombucha brewer, potentially like yourself, and I found that there was a regulatory limit of 0.5% alcohol in non-alcoholic beverages, and so I ended up inventing this machine, and now over 200 brewers around the world have one of my machines. And today I want to show you how to calibrate this machine. It is very, very easy, and I'll be doing it all in one take in this video to show you exactly how easy it is. The first thing that you need are these alcohol standards. So this one in particular is 0.1% ABV or alcohol by volume, and we'll pour it into the tube here. These you can just make on your own. This is just diluted vodka. So now that this device is warmed up, I can turn it on and screw in the first sample. And I'll be talking through the process as we go through all of the samples. So don't get too worried. I'll go fast in the beginning. But the idea here is we want to measure all of these alcohol standards, 0.1, 2.5, 0.5, 1, and 2% ethanol in this detector, and then enter all of the values in this Excel spreadsheet here. So I'll clear this Excel spreadsheet from the previous data, and we'll begin recording data in here. So we'll take a peek at the reading. You can see the reading, but I can't. So the reading for the 0.1% is 506. So we'll put 506 in here, and then we'll dump out this sample. Pardon me. We'll dump out this sample into a little waste bottle here. And then we'll pour the next sample. So this is 0.25%. So we'll pour this in. We're pouring about to the 20 milliliter line. Really, you don't want to go past 25 milliliters in here, but the good part about this detector is you don't have to have an exact volume in the tube. So about 20 milliliters is what you want to target for. So you can see the air is bubbling vigorously through the liquid. This is exactly what you want to see with your machine. If you have too little volume, then the air tube won't reach the liquid, and then you won't get that vigorous bubbling. So we can look at this next reading here. It is 576. And, some people stress about, having exactly the right number. But as you'll see in a minute, when we look at the actual calibration sheet, the difference between a raw reading, which is the units that the detector gives, the difference between about 5 units of raw reading is roughly maybe 0.05%, something like that. We'll see that in a second. But you can see the difference already between the 0.1% and 0.25%. The difference is 70 units, right? So that means, within a range of 0.15%, 70 units, maybe it's 0.01% per unit within this range. So, you may see 577 on the screen and say, oh, Nick, you put down 576, but it was actually 577. 1 or 2 or 3 units really doesn't matter that much. So we're looking at a reading now of 637. So we'll put 637 in here, and we'll read the next sample. So what happens as we read the sample is that the alcohol readings will rise, and then they'll eventually start to fall back down. And you'll see on the screen of your alcohol detector that there are 2 raw readings. So we'll look at that now. Hopefully this camera is looking good, but you'll see a higher reading, or you'll see 1 reading on the left and 1 reading on the right. The reading on the left is the highest reading that the detector has seen since the button was last pressed. So if you press and hold the button, it will turn off the motor and it will reset that reading. And when you go to read your next sample, you'll press the button to turn the motor back on again, and it will reset the reading again. And that way, what happens is the alcohol readings will rise as you measure your sample. They'll rise, 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 rise. And as you actually remove alcohol from your sample, the readings will actually start to go back down. And so that's why we want to hold that top position, because that's going to be much more accurate. So this one is 692. So we'll put 692 in this position here. Another thing that you'll notice that I'm doing is I'm reading all of the samples in order. And that eliminates some bias here. So if I were to go through and read 0.1%, then read 0.1% directly after, it would be a little bit more biased for that lower alcohol percentage, and it just wouldn't give an as accurate of a calibration curve. And so to be certain that our calibration curve is good and to not have any bias for low or high alcohol content, we're going to run through all of the samples and then run through all of them a second time. So now we're at the 2% sample. If you're measuring, lower alcohol percentages, if all of your kombucha is below 1%, there's really no need to measure the 2% sample at all. This one is reading 737. A lot of the brewers that have my machine follow this calibration curve and use these calibration samples, but in reality, that's not something you need to see as a limiting thing for you. You can change the calibration curve to whatever values you prefer, but this is just best in my experience for all brewers, right? Because there are some countries where the alcohol limit is 1.25%, and in that case, you would want to measure the 2% sample so that your data is included in the calibration curve. And you can see even after we've measured just one of each of the samples, we already have a pretty smooth calibration curve here, which is really great. Our line, and what I mean by a smooth calibration curve, the things that you want to look out for are your line of best fit is going through most or all of your data points. The last data point is always sort of going to be hanging on at the end. That's okay. But like if this data point, for example, was way up here or something like that, then maybe you made your standard wrong, or maybe you had some error in measurement, you used too small of a sample, or you didn't let the measurement go for long enough or something along those lines. And we don't want to look at the prediction yet. We don't care about that yet because we haven't updated these constants up here, which I'll get to in a minute. And you notice that I took a little break from reading the samples, and that's because we want to let the readings fall back down before we start with a low alcohol percentage. You might have noticed how I said you should press the button to turn off the motor and then press the button again to turn on the motor when you want to measure your next sample. That's the case if you're measuring your kombucha samples, which may be unknown alcohol levels. With these, you know every next step is going to be more and more alcohol, so resetting that higher reading doesn't really matter. And the other thing that doesn't really matter in the case of the calibration is that the sensor will be increasing in readings and increasing in readings for each of the samples. And so we don't need to give it time to sort of reset back to baseline because we only care about that highest reading. But when we measure all of these and then we go back to the 0.1%, we do want it to reset and sort of zero out. So I'm giving it a little bit of a rest. And I also flicked out the tube pretty good. Best practice would probably be to rinse out that tube, but I don't have water in front of me. And if you want to, you can even clean down these downstem pieces with a paper towel or something like that. And if they get really dirty, you can always wipe them down with soapy water. And the air tube is actually completely removable. And so is the temperature sheath, the temperature probe sheath. That's completely removable if you really need to clean it. But I would recommend just cleaning it while it's in place. So what I mean by resetting down to the bottom is the reading now is 437, and our lowest reading, which was 0.1%, was 506. So our raw readings are way below the lowest measurement that we took. And so it's pretty safe to say that we can go on and measure the next round of samples. So we're going to do the same thing in duplicate. So I'm going to press and hold this button and screw in this sample. You can screw in the sample and then press the button, or press the button and then screw in the sample, whatever boats your float, whatever is easiest for you. So now we're measuring 0.1% again. And like I said in the beginning, you're going through all of these samples and you may stress about 1 or 2 or 3 units here. And we'll see that as we go through again, we might see slightly different raw readings. Don't stress, just collect the data. And if there's variation, or if you're really worried about the variation, you can send me the document. But 99% of the time, you're going to see some difference in the readings every time. So what are we seeing now here? Now we're seeing 517. And, some people might see this and panic and say, my first reading was 506 and my second reading was 517. go ahead and look at that curve. Those data points still fit pretty solidly on that line. And when we look at the prediction of these readings, you'll see that they're within the expected error of this machine. Speaking of which, if you do your calibration curve perfectly or as perfectly as you can, the error that you should expect to see in your kombucha samples that you test should be plus or minus 0.03%, roughly that. That's going to depend on a few things. Part of it is going to be, how precisely you make your calibration standards, which honestly is not that difficult to make them pretty precise. And the other thing is going to be the temperature at which your calibration samples are. So I'll talk about that in a second, right after I write this down. So this one is at 578. So the first time we measured this at 576, this time it's at 578. You know, despite what I said earlier, a little bit of variance not being that much, it is reassuring when you measure your duplicate sample, 5 or 10 minutes later, and it's exactly the same, or, within 2 units. And you can see that again, just looking at your calibration curve, you can sort of visually have that indicator of like how far away are these samples from each other. So now we're measuring the 0.5% sample. One thing I did not mention yet is the temperature of these samples should all be the same. So I would recommend making about 500 milliliters at a time of these calibration samples and storing them in the fridge, because there can be microorganisms that grow just on alcohol and distilled water. I've seen it before. But if you use distilled water and you're not spitting in them or something, then they're probably going to stay sterile. So what you can do, if you would like, is you can make them, put them in the fridge, and then leave them out overnight, the night before you want to use them, or just for a couple hours to get them all to the same temperature. So that temperature is important because this detector is giving readings that are dependent on temperature and pressure. What do I mean by that? As you blow air, which is what this machine is doing, as you blow air through the sample, some of the alcohol from the liquid is going to evaporate. And that's what we're measuring inside of the machine. This is like a breathalyzer for liquids. Some of the air is going to, or some of the alcohol is going to evaporate, and the amount of the alcohol that evaporates from the sample is going to be directly proportional to, or not directly proportional, but it's going to be proportional to the temperature and the pressure. So you imagine a hot, like a hot mulled wine, you can smell the alcohol coming off. If you have a warm alcohol solution, more alcohol is going to come off. Or if you have a lower pressure environment, more alcohol is going to come off. It's more free to evaporate with less pressure bearing down. And that's why we need to calibrate this machine. So I know all of these samples should be about the same temperature, and they've all been about 20 degrees Celsius. We're going to put 692 for this one. That's the reading on that one. And as far as the precision of how close you need to be in temperature, I would say within 1 degree Celsius, you're pretty good. But the closer you are, the better. I wouldn't stress over 0.1 degrees Celsius or anything like that. We're now on our last sample, and our previous samples were really excellent. So for 0.25, we got 576 and 578. For 0.5, we got 637, then 638. For 1%, we got 692, and then 692 again. Very cool. This is all excellent data so far. Let's see what 2% says. So 2% is 741, which is a tiny bit higher than the first time we measured it. And now we have our calibration curve data completed. The last step here, I'm going to go ahead and turn off the motor in this machine. The last step that we need to do here is take the information from this graph and put it into the constants box here. You may have a version of this Excel document that does this automatically. If so, it will say that here. But just in case you don't, or if you have the Google Sheets version, I'm going to show you what to do. This right here is your equation. So really, you can just go in and copy this exactly how it is, Control C, and then Control V, and paste it right there. And then you need this number right here, just like this, and paste it directly in that box. And I'm just going to paste it match formatting so it looks nice. So that E there is signifying times 10 to the power of whatever. So the E does matter. You need to put that E in there. It's part of the number, I promise. So this is actually a very, very tiny number, and this is just 7.97, even if the E doesn't matter. Leave the E there just to be safe. And now we can finally look at this prediction column and see what the alcohol detector would say the alcohol percentage of these samples are based on our calibration curve, right? So for the 0.1%, the first one read 0.09 and the second one read 0.1. For the 0.25, spot on 0.25. For the 0.5, it read a little bit higher. For the 1%, just a tiny bit higher. And then for the 2%, it read a bit lower. Now, this all incorporates the error in measurement here as well. So I would say if your curve goes through your data points visually very well on the graph, then you're doing really well. And another metric that you can look at is here, this R squared value. If it is 9.9 and higher, then that's a fantastic calibration curve. If it's 9.5 or higher, then it's pretty good. And if it's 9.0 or higher, then it's okay. Anything lower than that, I would contact me and send me your Excel document or your Google Sheet so I can take a look at it for you. But this calibration curve is really good. We can see our error here and then our percent error as well. And I would say this is a very good calibration curve, almost excellent. I'll try harder next time. So now what we can do is use this calculator down here with our kombucha samples, which you can go in another video and see. One last thing that I didn't mention is that I didn't use oil in any of these samples. So if you're measuring kombucha or any other beverage, you want 1, 2, or 3 drops of any neutral oil. I like to use vegetable oil in each of your samples. But since we're just measuring water and ethanol here, they're not going to foam up and get foam inside of the machine. And so just you don't need the oil for your calibration samples. So that's the calibration in a single video. I think it's around 15 minutes long, and I was yapping the whole time. If I'm not yapping, maybe I could do it in 5 to 10 minutes, but maybe test me on that one day. So thank you so much for watching. I hope this was helpful. If you have questions or concerns, put them in the comments below. I'll see you in the next video. Bye.